Hello and welcome to the Screencast on reflecting exponential functions across the x-axis. We have already established that any exponential function of the form g of t equals ab to the power of t plus c, where a and b are positive real numbers with b not equal to 1, is always concave up and is either always increasing or always decreasing. We've also established that the constant a is a vertical scaling of b to the power of t, and so when combined with the vertical shift, the y-intercept is at 0, a plus c. The vertical shift also affects the range, causing the range to be all real numbers greater than c. Lastly, we have established that when the growth factor b is between 0 and 1, then the function tends to c as t increases without bound, using this arrow notation as shorthand. And when the growth factor b is greater than 1, the function increases without bound as t increases without bound. In this final video on transformations of exponential functions, we will see how reflections across the x-axis affect the graph of f of t equals ab to the power of t. Consider g of t equals ab to the power of t, where a is negative and the growth factor b is between 0 and 1. From our previous study of transformations, we know that g of t, the yellow graph, is a reflection of f of t across the x-axis and a vertical stretch by the absolute value of a. Notice the characteristics of the function g. We see that because of the reflection across the x-axis and the vertical stretch, g is always concave down and increasing. G has a y-intercept at 0, a, where a is negative, and g now has an upper bound to its range. The range of g is all real negative numbers. And lastly, we see that g tends to 0 as t increases without bound. Using our familiar arrow notation, we represent that as g tends towards 0 as t increases without bound. Now let's look at an example of exponential growth that has been reflected across the x-axis. Here we have g of t equals ab to the power of t, where a is negative and the growth factor b is greater than 1. We see that because of the reflection across the x-axis, g is always concave down and decreasing. G has a y-intercept at 0a, where a is negative, and again, g now has an upper bound to its range. The range of g is all real negative numbers. And lastly, we see that g decreases without bound as t increases without bound. Using our familiar arrow notation, we represent that as g decreases without bound as t increases without bound. It's an important skill to be able to look at a transformed exponential function and form an accurate mental picture of the graph's main features. In future activities, you will explore these ideas further and then use them to model real-world phenomena.